Good afternoon everyone. I am going to present few ideas for reactive power compensation of overhead AC transmission line using underground power cables. So the introduction. Overhead high voltage transmission line when loaded always consume reactive power. Uh, in contrast to that, underground power cables uh, underground power cables supply reactive power as they are inherently draw charging current. Figure first A shows a two-bus overhead transmission line model and figure 1B shows the corresponding phasor diagram. The sending and receiving end voltage have a phase angle difference of delta, which can be seen in the phasor diagram, that the Vs and Vr have a phase angle of delta. This delta is known as power angle. As the sending and receiving ends are in series, which can be seen in upper figure, they are in series. The current Is and Ir are equal, and the Is and Ir are equal, and the angle between the Vs and Is is delta by 2. Similarly, Vr and Ir is delta by 2. In this type of figure, in this type of circuit, the voltage at the midpoint is lowest of the transmission line. So now we now in figure 2a, this shows the overhead transmission line model in which a capacitor is connected in the midpoint of overhead line. As it can be seen in the figure that the midpoint of transmission line is connected by a capacitor. The next figure, figure 2b, shows the introduction of capacitor as midpoint may cause midpoint voltage to rise beyond 1 power unit even during the normal operation. So the capacitor connected draws charging current IC, which compensates the lagging component of the sending end current Is. Thus earlier it was seen that the sending end current, when there was no capacitor, the line consumes reactive power, and the reactive power was fed by the Vs. But now the capacitor fed the reactive power, and no, the source will not fed the reactive power. If the capacitor is sufficient, like properly designed, the reactive power requirement of the line will not be any phase difference between Vs and Is and Vr and Ir, which can be shown in the below figure, that if the capacitor is properly designed and properly of the proper capacitance, there will not be any phase difference between Is and Vs and Ir and Vr. This results in unity power factor at both receiving and sending end. The figure 2b, as I have explained figure 2b, as it can be seen from figure 2b, that the midpoint voltage Vm can be more than 1 per unit during the normal operation. To solve this problem, like if we want to reduce the voltage like from 1 per unit, less than 1 per unit, this capacitance can be splitted into many smaller capacitances and connected in the line. We can divide the line into multiple sections and use smaller capacitance instead of a large capacitance. Uh, so as underground power cables have large capacitances and a large capacitance, hence can be used to achieve same functionality as shunt capacitor. Like in transmission line, the line have inductance, and we uh, we have to compensate the reactive power. So in between the lines we can connect underground power cables for the compensation of reactive power. So what are the advantages? Insertion of power cable results in the following advantages. We can achieve unity power factor at both ends, like sending and receiving end. It increases the overall power transfer due to decrease in line impedance. As the length of line decreases, by insertion of underground cables, the line impedance decreases and increase in overall surge impedance loading of the line. So as SIL surge impedance loading increases, the power transfer capability will increase. Improvement in transient stability of the system, as we can transmit more power at a smaller power angle. The power angle will reduce as the difference between Vs and Vr is reduced, so we can transmit more power from sending to receiving end. Extension of the concept of to the cable. As the cable itself is a huge capacitance, the capacitance and the length of the cable can be calculated by using some maths, like how much length of cable should be added in the overhead line to get proper compensation of reactive power. When we insert a cable to an overhead line, the length of overhead line reduces, as we have discussed earlier. The length L of the line is reduced by the length of LC. LC is the length of the cable inserted. So the for the same transmission distance, this lead to decrease in overhead line inductive reactance. As the length of line reduces, the reactance of the line also reduces. After this, we have one more advantage, like many places we have constraints of acquisition of land for overhead line distribution poles and all that. That can be also reduced to some extent by using underground power cable. The land acquisition problem associated with the construction of new lines and like already existing lines can also be reduced. So we can conclude, like, by using underground power cables in conjunction with overhead transmission line, we can compensate the reactive power requirement of a loaded overhead line. Thank you.